Hello and welcome everyone. This is Manish from Skillable India. In today's session of geometric dimensioning and tolerancing, we are going to start with the parallelism. Okay, so in this particular session, we are discussing about the parallelism. Whenever the relationship between the feature is 0 degree or 180 degree, then we can apply the parallelism. Okay, so we can only apply at 0 degree or 180 degree. So we can apply the parallelism. So parallelism is the third geometric control under the orientation control. Okay, so this is very important. And with the help of definition, we will understand this, that parallelism is a 3D geometric dimensioning and tolerancing. Okay, orientation tolerance, which maintains that two part features are parallel to each other. Okay, so why we are saying that two part feature, we are talking, when we are saying two part feature, we are talking about the surfaces. Okay, two parallel surfaces. So whenever there are two parallel surfaces of the part, let's say these are two parallel surfaces. Okay, so these can be considered as two parallel surfaces, and one we can take it as a datum. Okay, so at one we can use it as a datum, and with reference to datum A, we can check the parallelism of this surface. Okay, so we can apply the tolerance, parallelism tolerance in case of with the reference to datum A. Okay, so you can use it to control center lines. Okay, so we can use for this center lines, center planes, cylindrical or and planar surfaces. Okay, so only not only for planar surfaces, we can use this tolerance for the cylindrical surfaces also. Surfaces parallel to datum elements. Okay, so one reference element is required. In this case, we are using the datum reference. Okay, so any feature is going to be parallel with another feature. So this is a related tolerance zone. Okay, so this is the related tolerance. So here relative to the datum, yes. So we know that orientation control, all the three orientation control, either it's angularity, perpendicularity or parallelism. So all the three tolerances are in the related tolerance zones. So they are relative to the datums. Okay. Maximum material condition or least material conditions are applicable. Okay, because this orientation controls in this parallelism, parallelism can be applied to feature or feature of size. Okay, so whenever we are talking about the feature of size, then we can apply the maximum material condition or the least material condition modifiers in the feature control frame. Okay, so in the second compartment of the feature control frame, we can apply the maximum material condition or the least material condition modifiers. This is the symbol. Okay, so whenever we are using two lines under the square, okay, so this is the symbol of parallelism. Okay, so this is the most important part. Now with the help of example, we will understand. Okay, so this is a top surface. You can see in this is the top surface of the part. Feature is having 0 degree with the bottom surface. Okay, so this surface, this top surface is at 0 degree with the bottom surface. Okay, so you can see these both the surfaces of the part are parallel to each other. This surface and the bottom surface, okay, of the part are parallel to each other. Now in this case, what we are going to apply, so you can see this surface can be applied with parallelism. Okay, so we have already know whenever there is a 0 degree or 180 degree, so we can go with the parallelism tolerance geometric control. Okay, with 0, you can see that with 0.1, this is the feature control frame. In this feature control frame, we have used the parallelism, and 0.1 mm of tolerance we have given over here. Okay, with reference A. So you can see the bottom surface of this part I have used as a datum, because this is a relative feature, related tolerance. Okay, so we want the datum. So in this case, the bottom surface I have used as a datum to check the parallelism of this upper surface. Okay, so whenever we are we have a drawing like this. The interpretation is from the datum surface. Okay, so this is the datum surface. There are two parallel planes parallel to datum A. Okay, so you can see that this 0.1 mm, so this 0.1 mm apart. So there are two parallel planes. Okay, so these I have shown over here in this line. So these are the two parallel planes parallel to datum A, which are 0.1 mm apart. Okay, the actual surface have to be within the tolerance zone. So when whatever the tolerance will be, the tolerance should be within the tolerance zone. Okay, it can be anywhere between 0.1, but it should be in, it can be in taper position. Okay, it can be like this also. But the thing is, it should always be within the tolerance zone. So the center is actual surface, which is not exactly parallel. So if this is a taper surface, okay, so it is not going to be parallel with this surface. But but it is within the two parallel planes. Okay, this parallel plane and this parallel plane. So the surface is within the two parallel planes of 0.1 mm apart. The actual surface is considered to be parallel with the surface A. So this is also considered with, to be parallel with the datum A surface because it is within the tolerance zone. Okay, so tolerance zone for parallelism applied to a surface of two parallel planes. Okay, so this is very important. So whenever this is a case, if it is in a bit within the tolerance zone, so it is acceptable. Okay, so the parallelism tolerance we have applied in the first compartment of the feature control frame. In the next compartment, 0.1 mm tolerance and with reference to datum A. Okay, so this is the most important one. Now this is for the while we are applying parallelism to a surface or a feature. Okay, so when we are applying parallelism to a feature, we don't have want the we cannot take the maximum material condition or the least material condition or the material condition modifiers. In the next example, when we are applying parallelism to a axis or to a feature of size. Okay, so for if we are applying axis, so this is the feature of size. So whenever we are applying parallelism tolerance to a feature of size, so here we have an example. So with this example, we will understand, okay, of parallelism applied to a feature of size. So there is a hole. You can see this hole. In this example, you can see this is a hole over here. Okay, this is a 2D overview. So the axis of the hole is parallel to the datum A. In this case, also the bottom surface we have used as datum A. Okay, so it is shown over here datum A. So the axis of the hole is parallel to the datum A. So what the axis of the hole is going to be parallel with the datum A. Then we can apply the parallelism. Okay, because this is also 0° with the it. Okay, in this case, this hole which is having 0.1 mm of tolerance. So this 0.1 mm having a diameter. Okay, 0.1 mm diameter. This is tolerance zone 0.1 mm diameter. Okay, so to the actual meaning of this, there is a cylindrical tolerance zone. So in this case, this is whenever we are talking about the whole axis, so there is a cylindrical form of tolerance zone. Okay, not two parallel planes. In the previous example, we have seen two parallel planes are there, but in this case, there is a diameter 0.1 mm of tolerance zone. Okay, so you can apply like this also over here diameter symbol. Okay. So which is parallel to datum A, the zone dia is 0.1 mm. The actual axis of the hole must lie within the cylindrical tolerance zone. Okay. So whenever, if there is a axis deviation, let's say, sorry, there is a axis deviation. It is in taper. Okay. But if it is within the tolerance zone, if this tolerance is within the tolerance zone axis, so it will be considered as a uh, parallel with the datum A. Okay, so the axis of the is now considered to be parallel with the datum A if it is within the tolerance zone. As usual, parallelism is applied to a feature of size. In this case, so we can apply the maximum material condition over here. So this is the symbol you can see over here. We can apply the maximum material condition or the least material condition modifier. Okay, so in this case, if the whole is produced, let's say if I am using plus minus 15 plus minus 0.2, okay, let's say we are applying. So at for whole, maximum material condition will be 14.8. Okay, so when 14.8, tolerance will be 0.1 mm. The geometric tolerance will be 0.1 mm. Okay, when we will move from MMC towards LMC condition, which is 15.2, the tolerance will be 0.5 mm. Okay, as we move from MMC towards LMC, we will get more and more tolerance. Okay, when because we can apply the maximum material condition modifier. Okay, so we are getting the bonus tolerance, or and I have already told you that how we can calculate the bonus tolerance by adding up the geometric tolerance to the size. Okay, so this is all about the parallelism we can apply to a feature or a feature of size. Okay, so if you have any confusion, you can write it down to the notes, and definitely we are going to discuss that problem. Okay, so this is all about parallelism. In the next section, we are going to move towards the position tolerance. Okay, so this is all. Thank you. Thanks a lot.